because I couldn't hear anything out of my right ear, but apparently we didn't have sound. Okay, we have sound now. All right, well, Gay-Lussac formulated the law of combining volumes. That's about all that you've got. So, yeah, you haven't lost anything yet. He said that gases, and this is an important note, if you remember the combined gas law, gases at the same temperature and the same pressure react with one another in volume ratios of small whole numbers. For instance, if we have hydrogen gas and chlorine gas creating hydrochloric acid, then if we have 1 liter, because the um, coefficient of hydrogen is 1, and 1 liter of chlorine, because the coefficient of chlorine is 1, it creates 2 liters of hydrochloric acid. You're looking at me. Do you follow? Did you follow? Before, we said 1 mole plus 1 mole makes 2 moles, necessarily. But this is exactly the same concept. Let's try another example. 2H2 plus O2 makes 2H2O. So 2 liters of H2 plus 1 liter of O2 makes 2 liters of H2O gas. Okay? Is this hard?
Not yet.
Okay. This brings us to Avogadro's law. Avogadro's law says that the volume of a gas, if you keep it at the same temperature and pressure, is directly proportional to the moles of a gas. All this is pretty basic, but hopefully you realize what we're doing is setting up the ability to use stoichiometry with volumes instead of with moles. Because right now, what you're used to is moles. We're going to make it so that you can do it with volumes. Which brings us to MV, the molar volume. If you remember the molar mass, and the molar mass changes depending on the thing. The molar volume is the volume that a mole of gas occupies at STP. And molar volumes are actually easier to calculate than molar masses are. The molar volume of 1 mole of any gas at STP is 22.4 liters. Now you might be confused from this, so let me try to explain. A mole of hydrogen gas at STP occupies 22.4 liters of space. You follow me? A mole of oxygen gas at STP occupies 22.4 liters of space. A mole of nitrogen gas at STP occupies 22.4 liters of space. A mole of any gas you want to come up with occupies 22.4 liters at STP. Or in other words, the molar volume of anything is, any gas is 22.4 liters. So if you need to calculate what the molar volume is, it's 22.4 liters. Is everybody good on this one? Do you understand at this point in time? I'm sorry, what?
So I know it's going to be a quiz question now.
Yeah, which is the reason why I can't just let you write it down on a chart or anything like that, because I got to ask it to you in a quiz question. Sorry. Otherwise, I just let you write it down on the chart. Does everybody understand? Sorry, I'm trying to multitask here. So, if I had 7 moles of carbon dioxide at STP, 7 moles of carbon dioxide, 1 mole is 22.4 liters, 7 moles of carbon dioxide occupy 157 liters at STP. You know where this is going to get a little harder, right? Because we keep saying at STP, but what's the problem?
We don't keep it in STP.
It's not always at STP. So to get it to STP, we'll have to use the combined gas law. So, how many moles?
One.
470?
Yeah. That's my estimated guess.
Anybody else?
Ten? Do I need to change it to something? Because I definitely cannot do that in my head.
Twenty, 228 divided by 22.4 is about 10. All right, what volume will 4 moles of ammonia occupy at STP? Four moles. 1 mole is 22.4 liters. And this is where it starts to get a little trickier. What volume will 2.5 moles of hydrogen gas occupy at 300 Kelvin and 400 torr? What do you need to do?
Kelvin to Celsius.
Well, first thing you'll need to do is go from moles to liters,
Yeah.
and then convert from STP to 300 Kelvin and 400 torr using the combined gas law. So like I said, the first thing we'll need to do is convert from moles to liters. But that's at STP. So from there, we will need to use the combined gas law to convert it to non-standard conditions. Enter it into your calculator, and you get 117 liters. Questions? I'm going to take that as a no, I guess. All right, I'm going to let you work on this one. A sample of oxygen gas occupies 1 liter when its temperature is 190 K and its pressure is 129 kPa. How many moles of oxygen are present? How do we go about doing it? Before I give you a minute to try.
You would have to convert it to STP.
The first thing you do is convert it to STP, and then from there you the first thing you do is convert it to STP, and then from there you convert it from liters to moles. What do you think, Caden?
I'm still. I haven't caught on quite yet.
Hey, where's the problem? Anybody else want to answer the same question? You got a problem? Where's the problem? I've given it to you in non-standard conditions in liters, and I need it in moles. To go from standard to non-standard, you use the okay, cool. Nobody knows.
Combined gas law.
Combined gas law. Then to go from liters to moles, you use the molar volume. So, let's back this up. In the last problem, you were given it in moles and asked to convert it to liters at non-standard conditions. So you use the molar volume to convert it from moles to liters. You with me? Basically, that means you multiply the moles by 22.4. One mole is 22.4, 2.5 moles is 56. Then, that gives it to you at STP, standard conditions. I need it at non-standard conditions. So standard conditions at torr is 760 torr, and for Kelvin, it's always 273. So we're at standard conditions, or 760 torr. We calculated the 56 liters in the last part of the problem, and we're at 273 Kelvin. We want to convert it to 400 torr and 300 Kelvin, and we're trying to figure out the volume. So then it's just cross multiply and divide. P1 V1 over T1 equals P2 V2 over T2.
Could you go back to the sample 4 again? So I just
Sure.
look at the original.
Sample 4 is done the exact opposite of sample 3. You're given volume at non-standard, and you're wanting moles. To go from volume at non-standard to moles, you have to go from volume at non-standard to volume at standard to moles. Non-standard to standard
Sir.
is the combined gas law.
I still don't understand how I'm going from liters to moles. I get that if you're going from
Molar volume. 1 mole, 22.4 liters. If you're given liters, divide by 22.4. If you're given moles, multiply by 22.4.
if you're given liters, how do you get 56?
This is a different problem.
Oh, you multiply from top here.
This was sample problem 3,
The,
not 4.
you have,
Oh my goodness.
So in this case, I'm given moles.
22.
That's why.
I wanted it non-standard.
It's just one.
So then what am I doing?
Pardon?
So then what do I do?
You got to go from moles to volume at standard, then from standard to non-standard.
Okay, will you do that with
That's
this
why.
problem?
That's why you went up.
Pardon?
Will you write that out with this problem?
I did.
Makes sense.
I didn't see that yet. 'Cause that, I don't know.
This is the last problem, not the problem we're doing in class.
Once we get to that, we have to convert
The problem we're doing in class, I want you to take a shot at doing it before I put it on the board for you. So this case, we're at moles. I want to get to non-standard. So to go from moles to volume, I multiply by 22.4.
But then you have to go to non-standard.
But then I have to take that 56 that's at standard, and I have to go to non-standard. To do that, I need the combined gas law. Do you understand? So standard conditions for P1 is what?
No, because that's
What's the pressure? What is standard pressure?
760.
Standard pressure is 760 torr, or 1 atmosphere, or 101.7 kPa.
Renee, you do what?
But this problem, we're doing it in torr. So I did it in 760 torr. Do you understand? P1. V1 is what we calculated. The initial volume, 56 liters. T1 is 273 Kelvin because it's always going to be 273 Kelvin when it's standard temperature. Standard temperature is 273 Kelvin. You with me? You with me, Levi? You understand? All right. Now then I gave you some non-standard conditions. I told you 400 torr. That's the non-standard. I'm looking for V2. And I gave you 300 Kelvin. These are non-standard. Those are standard. Those are non-standard. Multiply. Divide. 117 liters.
Is that it?
That's the answer. Now for this problem, the one I had you doing, it's the reverse. You're going to start here and work your way backwards. So you start with 1 liter at non-standard conditions. So if it's 1 liter at non-standard conditions, the first thing I've got to do is convert it to standard conditions. And to do that, I need the what do I use? Thus far, what have we gone over in this chapter for math? Three choices here. We've gone over Dalton's law of partial pressure. We've gone over the combined gas law, and we've gone over molar volumes. These are the three tools you have to choose from. If you're trying to go from standard to non-standard conditions or non-standard to standard, which one of those 3 puppies do you use? You use the combined gas law. Molar volume is used to go from moles to liters or liters to moles. The combined gas law is used to go from standard to non-standard or non-standard to standard. And Dalton's law of partial pressure is used to remove water vapor. Remove vapor pressure. Does everybody understand this? You write this down. I'm happy if you write it down if you can't remember it. Those are the 3 things we've gone over thus far this chapter. Molar volume, which changes from moles to volume or volume to moles, which is kind of why they call it molar volume. You laugh, but it's actually the function of it is in its name. The combined gas law, which changes from standard conditions to non-standard conditions or non-standard conditions to standard conditions, or frankly, it can change from non-standard to non-standard if that's what you needed to do. And then Dalton's law just for vapor pressure. It's the least used of the 3 things we've learned to do here. It takes the vapor pressures out of wet gases. For this one, we start at non-standard volumes. To fix that, we need to go from non-standard volume to a standard volume, and then if you're at a standard volume, you can use the molar volume to go to moles. No, not non-standard. Moles. But molar volume only works if you're at standard.
So then I'm not changing the liters to moles first. I'm going that second.
You are not. It's at non-standard first, so you've got to get it to standard before you can change it. Do you understand? Cool? Yeah? All right. Here, let's do it. So the first thing we've got to do is go from non-standard volume to standard volume, and then we can go from standard volume to moles. Non-standard volume to standard volume is going to be the combined gas law. So, 129 kPa, our initial 1 liter of gas, and 190 K. These are our non-standard conditions that were given to us. We want to take them to standard. What's the standard kPa? We're looking for volume. And what's standard temperature? Cross multiply. Divide. That brings us to 1.83 liters at STP. Now that is standard volume, but we're being asked for moles. So we're going to divide by 22.4, which gives us 0.0817 moles. Is that what you got?
Yeah, we kind of had a meeting of the minds.
Did he want to multiply by 22.4?
I did. Yeah.
We were like, it's either one. It's
It was
one
either
of
one or the other.
You multiply when you're going from moles to liters. You divide when you're going from liters to moles.
Okay.
Does that make sense?
Yeah.
If you actually set up the bridge like I did,
That's all.
it'll automatically lead you to where you need to go.
'Cause I have to
But I
keep
just
it.
always remember 1 mole is 22.4, so I would have to multiply by 22.4 when I'm going from moles to liters.
So, Mr. Moss, does it get harder than that?
Do you have your chart, your stoichiometry chart on you? Anybody have that stoic chart? Yeah, this one right here.
So, oh, yeah.
Okay, here's this chart. I just taught you to do 1 to 2 or 9 to 10.
No. Okay.
That's that step
Right.
on that chart.
So I think I know the answer.
Well, we've still got to figure out how to do all the rest of this.
So, okay.
So what we haven't done thus far is combine what we did last chapter with this. But we've got to figure out how to, we did 1 to 2 and 9 to 10. We got to figure out how to do all the rest of it. You've done 3, 4, 7, 8 before.
Right.
That's what last chapter was. But now you got to figure out how to do 1, 2, 4, 7, 9, 10. Or 1, 2, 4, 7, 8. Or 1, 2, 9, 10. Or 3, 4, 7, 9, 10. See, the big problem that comes with this chapter, and we're about done for the day. The big problem that comes with this chapter is the problems aren't hard to do, but sometimes they're hard to figure out what to do.
Yeah. I've kind of noticed that for sure.
I mean, once you know how to do it, but it's hard to figure out what to do, and that's what this is for. If you seriously rely on this thing will lead you through the direction you need to go. It even tells you volume of gas at non-standard condition, volume of gas at standard condition uses the combined gas law. It says it right on it.
Oh, that's nice.
And the same thing over here. It says it right on it. Here it says, going from volume of gas at STP to moles, 1 mole is 22.4 one mole over 22.4 liters. Here it says moles to standard conditions is 22.4 liters over 1 mole. It's on the chart.
And we're allowed to use that during
Yeah,
class, right?
yeah.
Nice.
You're encouraged to use it. You're not just allowed to use it. Can you do it without the chart? Sure, yeah, I did it without the chart.